Thanks for joining me today. We're going to be talking about a small part of a much larger idea. The large idea is solving quadratic equations, and the part that we're going to talk about today is using the algebraic method of completing the square. When we complete the square, it means you're going to manipulate the quadratic equation to have a perfect square trinomial on the left side of the equal sign, and then you can solve by taking the square root of both sides. A perfect square trinomial means the quadratic equation has two identical factors, and I wrote out some equations, some examples here. For example, x plus 5 times x plus 5, that's going to equal x squared plus 10x plus 25. And if you'll notice the pattern here, you're looking for the two numbers that when added together give you this, but when multiplied together give you this last term. And so 5 times 5 does give you 25, and 5 plus 5 does give you 10. So these are identical, so it's considered a perfect square trinomial. Here's another example using negative signs. Negative 6 plus negative 6 gives you this middle term, and negative 6 times negative 6 gives you this constant term on the end. Here's the same thing, I've just written them differently. Since these are identical, you can rewrite them as this quantity squared. So if I were to expand this, it would be x plus 3 times x plus 3. And then you see our x squared here. 3x plus 3x gives you this middle term, and then 3 times 3 gives you the constant at the end. One more example, negative 4 plus negative 4 gives us negative 8, and then this number squared, 4 times 4, gives you this. So all of these are examples of perfect square trinomials, which is what you're trying to create when you're completing the square. Completing the square. When we complete the square, we're always looking for an a value of 1 and probably an equation set to a number equal other than 0. For example, let me show you. This is when a clue that we would usually use completing the square. We've got 1 here. You can complete the square with quadratic equations that begin with other numbers, but it's a little bit more challenging. So for Algebra 1, we stick with the coefficient, a leading coefficient of 1. So once again, we've looked for this 1 here and the whole thing set equal to a number other than 0. If it were set equal to 0, we'd probably try factoring first before we move to completing the square. But since it is set to another number, we're going to try completing the square. So let's work an example. And I'm okay with the example that we just wrote down, so let's do it again. X squared minus 10x plus 29 equals 8. There's a very specific order of steps to follow when you're doing this, so I'm going to talk about it, and then I'm actually going to show you the steps written down in plain English. But the first thing I want you to do is you need to rearrange this equation. And you need to move this constant term, all constant terms need to be to the right of the equal sign. Now, of course, I can subtract 29 on both sides, and that's going to do it for me. So what I've got is x squared minus 10x. That big space is there for a reason, and it equals 8 minus 29. My next step is to look at this term, and it's called our b term or our middle term, and we're going to divide this number by 2. 10 divided by 2 is 5, and 5 times 5 is 25. So I need to put 25 right there. And since I added 25 to the left, I can't unbalance my equation. I've got to add 25 to the right. And once again, I came up with this number because negative 10 divided by 2 is negative 5. Negative 5 times negative 5 is positive 25. Now I need to go ahead and simplify both sides of this. And just like we talked about, we were purposefully setting up a perfect square trinomial. So I know that the two numbers negative 5 times negative 5 added together gives me negative 10, and negative 5 times negative 5 multiplied together gives me 25. So I know that I can factor it to this perfect square situation. And now I need to simplify the other side as well. And right here, I can go ahead and take an easy step. Negative 29 plus 24 is going to leave me with a negative 4. 8 minus 4 is going to leave me with a positive 4. So now I've got the equation x minus 5 quantity squared equals 4. And what I can do to deal with this square root, to deal with the square, is to take the square root of both sides. And this square root will cancel out the squared, and I can prove that to you later on in a different video. But so what we're going to end up with is x minus 5 equals plus or minus 2. And the reason it's plus or minus 2 is that positive 2 times positive 2 equals 4, and negative 2 times negative 2 equals 4. So you don't know which case you have, so we have to consider both of them. If you notice, I need to rewrite this. X minus 5 equals 2, and x minus 5 equals negative 2. Sorry guys, that's a minus. So now I've got two very simple algebraic equations that I can solve. Plus 5, x equals 7, and plus 5 and plus 5, where x equals 3. And I can leave it like that, or I can write it in brackets to indicate that the solution set is 7 and 3. And I could prove it. I could go back in and substitute 7 for x into my original equation, and I would get 8 as a result. I could do the same thing with 3. I could substitute 3 everywhere I saw an x in my original equation, and I would get 8 as an answer in that as well. Okay. That was a simple example. It worked out to a whole number. And as you become more experienced, you'll understand that if it works out to a whole number, you could have factored, but it's absolutely okay if you didn't. So let's try one that's not going to work out to a whole number so that we're forced to deal with some irrational numbers. Let's try x squared minus 18x plus 69 equals negative 10. First thing I'm going to do is rearrange my equation. Leave that space on purpose. I'm going to subtract 69 from both sides. And so now I need to go ahead and do that next step. I need to divide negative 18 by 2, which is 9, and I need to take negative 9 times negative 9, which is 81. Since I added 81 to the left, I have to add 81 to the right. And now I need to simplify. I know that on purpose I set up a perfect square trinomial on this side, so I know it factors to this. And if you start to see the pattern, negative 18 divided by 2 is negative 9. That number is there for a reason. This number, when added to itself or added together, negative 9 plus negative 9 equals negative 18, and when multiplied to itself, negative 9 times negative 9 equals 81. Now I need to simplify, and over here I've got negative 79 plus 81, and it looks like I'm going to end up with x minus 9 quantity squared equals 2. Okay, so then we're going to take the square root of both sides. And this does indeed equal x minus 9, but there is no whole number answer to the square root of 2. It's an irrational number. And instead of finding a decimal, which we could with a calculator, we're actually going to leave it as an irrational number. We still have to separate this into our two equations, plus the square root of 2, and x minus 9 equals the negative square root of 2. I need to simplify. So x equals 9 plus the square root of 2, and x equals 9 minus the square root of 2. And that's how we leave it. Unless you're told in the directions to make your answer in decimals, you need to actually leave it in this form. And it is an irrational number. It's not a whole number, but that's what the answer is, and it's okay to leave it like that. Just for fun, one more example. Actually, I'm lying. I don't want to do any more examples. The cool thing about completing the square is that it always works. You can even do it when the leading coefficient isn't 1. It just adds a few extra steps. I've written the steps down here in just plain English, and it would be really worth it if you would pause and take a screenshot of these steps and put it somewhere so that you know how to find it the next time you need to complete the square. Let's go through it real quick. Make sure the leading coefficient is 1. We did that. Let's rearrange so that all constant terms are to the right. Well, we took this minus 10 and we added 10 to both sides. Divide the middle coefficient, or the b, by 2 and square the result. 18 divided by 2 is 9. 9 squared is 81. We're going to add the squared number to both sides, plus 81 and plus 81, and then we're going to simplify. We've got x plus 9 squared equals 101, and then we're going to take the square root of both sides and simplify. Believe it or not, some kids prefer this method. Once they learn it, this is the one they'll always go to, because as long as this coefficient is equal to 1, these steps work every time. You don't have to worry about factors. Thanks for joining me. That's completing the square. If you find the other videos, we also talk about solving quadratics using graphs, tables, and also factoring in the quadratic formula. Thanks for your time.